This video is about proving triangles congruent, and it's found in your text in section 4-2. For two triangles to be congruent, all three angles and all three sides must line up perfectly. Is there some way that we could show two triangles were congruent without comparing every single angle and every single side? That would save some trouble. And also, if we had certain unknown sides or angles, we could use deductive reasoning to fill in the unknown information. For example, if we knew that A, B, C was congruent to triangle D, E, F, and suppose we knew that angle A was 30 degrees, then we could use deductive reasoning to conclude that angle D must also be 30 degrees, even if we didn't know that about angle D to begin with. First, let's go over some new terminology. The word opposite in this context means something specific. Side AB is opposite angle C. The way that I remember these two things are opposite, one way is that they're not touching. Another way is I can draw a ray through this angle that passes through side AB. Those are two ways that I sometimes remember opposite. So angle A is also opposite side BC. Again, I could draw a ray passing through side BC that has its endpoint at angle A. Here's another term that we need to learn. Side AB is included between angle A and angle B. The word included is somewhat intuitive. If we look at included between, we have angle A and angle B, and then side AB is this side right here. So the reason that it's included between is if we go from angle A to angle B, we could travel right along that side and get from the first angle to the second angle. So similarly, we say the same thing about an angle. An angle can be included between two sides. In this case, angle A is included between side AB and side AC. And that's even easier to see because side AB and side AC actually make up the two sides of angle A. And now get ready for a big postulate, the SSS postulate. SSS stands for side, side, side. And what this postulate says is that if three sides of one triangle are congruent to three sides of another, so let's stop and mark that for a minute. Side AB we're given is congruent to side DE, BC is congruent to EF, and AC is congruent to DF. Suppose we're given that, then the triangles are congruent. Notice that we didn't compare any of the angles in the two triangles. We didn't have any information about the angles to begin with, but we were allowed to conclude through this postulate that the two triangles were congruent. So note the structure of this postulate. It's an if-then statement. It has if, hypothesis, then conclusion. So we can write that out as a flowchart. If three sides of one triangle are congruent to three sides of another triangle, then by way of this new postulate, we have the triangles are congruent. So how could we use this powerful postulate? Well, one way is, suppose we're given that three sides of one triangle are congruent to three sides of another. We conclude that the triangles are congruent. We could draw another conclusion from the fact that the triangles are congruent. stop and think of some conclusion that you might be able to draw. There are several conclusions you might have thought of, but I hope some of them involved angles because we weren't told anything about the angles of the triangle here, and we figured out that the triangles were congruent. Now, by the definition of two congruent polygons, which we have abbreviated as CPCTC in the case of triangles, we can conclude that the angles of these two triangles are also congruent. That was not given information. We deduced it through this line of reasoning. Okay, now we have another big postulate just as powerful as SSS. It's the SAS postulate, and notice that the A in SAS, which stands for an angle, is between the S and the other S. So this can remind us that the angle we're talking about is included between the two sides that we're talking about. If two sides and the included angle of one triangle, so let's mark, for instance, suppose we have two sides and an included angle that are congruent. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Notice that we didn't have to compare angle B and angle E. We didn't have to compare side BC and side EF. We were allowed to conclude just from these three things, side, angle, side, that the two triangles were congruent. And that means that all of their parts are congruent. Now we have another one, the ASA postulate. Again, we have a clue from the name of it that the side in question is included between the two angles. If two angles on the included side of one triangle are congruent, two angles and the included side are congruent to two angles and the included side of another triangle, then the triangles are congruent. In other words, we didn't have to know anything about angle C and angle F. Just by knowing these three things were congruent, we can conclude that the entire triangles are congruent. Okay, let's do an example problem. Decide whether you can deduce by the SSS, SAS, or ASA postulate that another triangle is congruent to triangle ABC. If so, write the congruence and name the postulate used. If not, write no congruence. Okay, let's look closely. From the markings on this diagram, I only see two pieces of information. I see that BC is congruent to DC here, and I see that angle BCA is congruent to angle ACD. But these three postulates, in order to use any of them, we need three pieces of information. Two pieces of information will not do it. So knowing that these two sides are congruent and these two angles are congruent will not do anything for us all by itself. But notice that side AC is shared between the two triangles. And since any segment is congruent to itself, we can remind ourselves that AC is congruent to AC. And now we do have a side, an angle, and a side. Side, angle, and a side. And the angle is included between the sides that we know are congruent. So in this triangle, we do have congruence, and we can write we could write it correctly in several different ways, but I'm going to write it as triangle A, B, C. So I'm starting from A and going down to B and C is congruent to triangle. I'm going to start from A again and go along the unknown side towards D, just like I did towards B. A, D, and then down through this congruent side to point C. excuse me, I forgot to write the triangle symbol here. Triangle ADC is what's congruent to triangle ABC. You try one. Decide whether you can deduce by any of these three postulates that another triangle is congruent to triangle ABC. If so, write the congruence and name the postulate used. Let's back up for a minute. I don't think I named the postulate used in this last problem. SAS was the postulate that I used because I have a side congruent to this side, then an included angle congruent to an angle, finally another side congruent to itself. So it was the SAS postulate. So now you're equipped to do this problem and name the postulate used. If not, write no congruence. Okay, let's do one more example. Suppose we're given that AC, the segment AC, is parallel to segment UV. Let's decide whether we can deduce by any of these postulates that another triangle is congruent to triangle ABC. If so, we'll write the congruence and name the postulate. If not, we'll write no congruence. Okay, it appears like we have very little information unless we use this, what we're given about parallel lines, to deduce some angle congruencies. So there's an angle here, angle C, which by alternate interior angles must be congruent to angle V because we know these two lines are parallel. Also, we have angle A congruent to angle U, also by alternate interior angles using this other transversal AU. And by vertical angles, we have a third angle congruent. We have angle ABC congruent to angle VBU. So we do have three pieces of information that we could get about these two triangles. So can we use those to deduce congruency? Well, looking back at the postulates, the information that we have about these two triangles, we have an angle congruency, another angle congruency, and another angle congruency. So if that were a postulate, we would name it AAA. But that's not on the list up here. We don't have any AAA postulate that shows two triangles are congruent. So because that's not one of the postulates available to us, we have to write no congruency. Okay, you try one. If you're given that AB is parallel to CD and BC is also parallel to AD, decide whether you can deduce by any of these postulates that another triangle is congruent to triangle ABC. If so, write the congruence and name the postulate. If not, write no congruence. For further practice, see page 124 of your text, numbers 1 to 15, odd.